For as long as we've looked up, we've seen that red dot in the sky and wondered, are we alone? It's one of the biggest questions, right? And Mars has always been front and center in that whole conversation. So let's get into it. Let's join the hunt for this hidden world.
Okay, so before we can even really talk about Mars, we have to start right here on Earth, because to understand the search for life out there, you need to meet the toughest, most ridiculously resilient life form we know of. This little creature completely redefines what it means to survive.
So here it is, the tardigrade. Some people call it a water bear. And this tiny animal is, well, it's pretty much indestructible. Think about this. It can live for 30 years without a drop of water. It can survive the pure vacuum of space. It can handle radiation that would kill us in an instant. Scientists actually built a little Mars simulator for it. They blasted it with UV, froze it to minus 80 Celsius, threw in some toxic soil, and the tardigrade, it just kept on going. But then, the researchers tried one more thing. They added a single chemical, one that's super common all over the surface of Mars. And Earth's ultimate survivor? It died. Instantly. Just like that. So what in the world is this chemical? And what does this mean for our hunt for life on Mars?
Right? This is where our investigation really begins. It's all about this almost invincible creature, and the one thing on Mars that it just couldn't take.
The killer's name? Perchlorate. It's basically a type of salt, an oxidizing salt. And when it gets zapped by UV radiation, which Mars has plenty of, it turns into something like bleach. It just destroys any organic molecules it touches. And here's the kicker. Mars doesn't have plate tectonics or a lot of water to wash this stuff away. So it's been piling up in the soil for billions of years. It's a total death sentence for life as we know it.
Okay, so you're probably thinking, if the surface of Mars is a frozen, irradiated, bleach-soaked wasteland, why are we even bothering to look? It sounds hopeless, right? Well, that's where we run into the great Martian paradox.
You have to picture Mars billions of years ago. It wasn't the red desert we see now. It was a world a lot like a young Earth. It had a thick atmosphere, it had rivers, it had lakes, it even had a magnetic field to protect it. But Mars is small. Its little core cooled down, that magnetic field disappeared, and the solar wind just stripped its atmosphere away. That's what left the cold, barren planet we see today. But the key thing to remember is this: it once had everything life needed. And that's why we keep looking, because we keep finding these little breadcrumbs, these tantalizing clues. Way back in 1976, the Viking landers found what really looked like metabolic byproducts in the soil. And just recently, in 2023, the Perseverance Rover found these mineral patterns in Jezero Crater, and they look uncannily like the waste products that microbes on Earth leave behind. Now, it's not a smoking gun, but they're powerful hints that maybe, just maybe, something survived. So that brings up the question. Could life have found a way? Could it have evolved to handle those deadly perchlorates? And this, my friends, is where the story takes a really fascinating turn. We need to take another look at that poison. It turns out, perchlorate has a stunning secret. Yes, it's a lethal poison, but it could also be the key to life. Get this, there are microbes right here on Earth that actually eat this stuff. But even more amazing is this. Perchlorate is a fantastic antifreeze. It can keep water liquid all the way down to a mind-boggling minus 70 degrees Celsius. And suddenly, you can start to imagine a whole ecosystem. Picture this. During the cold Martian night, these perchlorates pull moisture right out of the thin air. They form a thin, super salty layer of liquid brine on the soil. A microbe that's been dormant could wake up, have a drink, and even munch on the perchlorates for food. Then, when the sun comes up, the water evaporates, everything goes dormant again, and the whole cycle is ready to repeat. It's a brutal way to live, for sure, but it's a complete ecosystem. So, what this all tells us is that if life is there, it's not going to be hanging out on the surface. No way. It's hiding. The question is, where do we even start to look? The hunt has to go underground, into the shadows. We start just below the surface, maybe a few meters down, where the soil itself can block the worst of the radiation. Then we go to the polar ice caps. The ice there is a fantastic natural radiation shield. After that, we have to go even deeper, into ancient lava tubes. These are huge natural tunnels that offer total protection. And the final, ultimate hiding spot? Kilometers down, deep inside the planet's crust. And this isn't just theory. We have actual missions designed to do this. The Rosalind Franklin Rover, for example, has a 2-meter drill specifically to look for biosignatures just under the surface. And there's a proposed mission called the Mars Life Explorer that would drill into those icy polar regions and run tests right there on Mars. But the most mind-blowing idea, the most exciting possibility, is way, way deeper than we can drill right now. Some studies suggest there could be huge aquifers of liquid water, maybe 10 or 20 kilometers down, kept liquid by heat from Mars's core. I mean, think about it. We have places just like that on Earth, with entire ecosystems that have been totally cut off from the surface for millions of years. So this whole search, from just under the dirt all the way down to the planet's core, it's all leading to one of the most profound questions we could ever hope to answer. What if the life we find on Mars is actually our family? There's this theory called panspermia. The idea is that life can travel between planets, basically hitching a ride on an asteroid. A huge impact on one planet can blast rocks into space, and those rocks can travel for millions of years before landing on another planet. And here's the crazy part. We know for a fact that we have rocks from Mars right here on Earth. And this is really the bottom line, the ultimate takeaway. It all comes down to two incredible possibilities. Scenario 1, we find microbes on Mars, and their DNA looks like ours. That can mean life here on Earth actually started on Mars, and we are, in a sense, Martians. Or scenario 2, we find life, but its chemistry is totally different. That would mean life isn't some cosmic fluke that happened once. It means life pops up on its own all over the place, wherever the conditions are right. And if that's true, the universe is probably just full of it. Either one of those outcomes is just staggering to think about. And that's exactly why we keep looking. It really brings to mind what the great Carl Sagan said. If we are alone in the universe, it seems like an awful waste of space. So in the end, the answer to that huge question, is there life on Mars, probably isn't sitting on the surface waiting for us. The truth, if it exists, is hidden. It's tucked away in the ice, buried in the rock, and maybe even thriving in the total darkness miles and miles beneath our feet. Finding even one single living cell would change everything. It would be the single greatest discovery we've ever made. So I'll just leave you with this to think about. What would finding life on Mars, even just one tiny cell, mean to you?